I guess I'm alone. Anyway, so, but 403. So let's just get started. If no one has anything else to distract me. Well, I guess that just means you guys like discrete math so much. Like, no, we don't want to talk about basketball and ramen and your desk. We'd rather do discrete math. And I know all these things are interesting. Therefore, discrete math must be more interesting. So welcome, everybody, to discrete math. Let me start sharing my second camera to get our whiteboard going. And yeah, today, if we have time, I hope we will. Oh, we have a chat already. What's happening in the chat? The least painful math. That's fun. That's a great way to look at it, son. I mean, I like to think that not all. I think that all math isn't painful, but it is kind of the most fun math because it's like, you know, I'm not asking you to solve a derivative or do trig subs or anything like that here. I'm just asking you like about cool stuff. And today, if we get to it, we're hopefully going to get to literally what I think is the most beautiful proof in mathematics. And it's largely considered that. And someone maybe died over it. And it's part of the reason I'm a mathematician. So it's kind of nice. So 50-50, we'll get to it. But anyway, the reason it's so beautiful is because we're talking about a new thing today that we started last time, and that is direct proofs, or indirect proofs. This is chapter 4.7, and we're talking about indirect proofs. And so far, we've gone over two forms of indirect proofs, and those are the only two we're going to go over in this class. Those are actually, I don't even know anymore. Maybe the only two. Those are contrapositives and contradiction. Contrapositive was real simple. A contrapositive proof just said instead of proving something directly, instead of proving it if then directly, prove it's contrapositive. That makes total sense. Contradiction is even cooler and a little different. That's what we're doing when time expired. So let's remember what a contradiction proof is. So last time I went through a whole wacky thing where we went over Legally Blonde, and it was awesome. But really, the bones of it is, like, stripping away all the BS there. The bones of a contradiction proof is to prove that for all x and d, p of x is true, assume the opposite. And this is the brilliant part of it. This is like some kind of weird Avatar philosophy where you like go the reverse direction, or some like car, yeah, go left to go right, whatever they're doing in that movie. Assume the opposite. Assume that there exists an x and d such that not p of x is true, right? Because that's the opposite of this, that's the negation. Assume that. Because then, if we can show there exists an x and d such that not p of x is true, or so if we can show that this logically leads to a contradiction, then it must be false. So the idea is you assume the opposite, and if you can prove that the opposite's true, it will lead to a negation, or sorry, it will lead to a contradiction. Well, if anything leads to a contradiction, it must be false, because we can't have contradiction. A contradiction, and I'll write it up here. A contradiction is a statement that is simultaneously true and false. So contradiction is a statement simultaneously true and false, which cannot happen. Why can't it happen? Because I say so. And by that I mean, this is like basically the most fundamental assumption we make in all of math. All of math is kind of built on this idea that contradictions cannot happen. Something can't be both true and false at the same time. If you don't want to live in that world, you're free to. But then none of math's going to make sense. So the point is, if we assume that something can't be true and false at the same time, that means that if anything leads to a contradiction, it must not be true. So the point is, if this guy, if they're existing in X and D, if the opposite leads to a contradiction, the opposite can't be true. And so if the opposite can't be true, then the original statement must be true. So basically what we're saying is, if the opposite can't be true, then the original claim must be true. That's all we're doing here. This is a weird, like, awesome lawyer trick we were talking about last time. Where you go along with it, you assume it's true, but then you show that that'll lead to something ridiculous, a contradiction. So then that assumption had to be false. That's kind of clever, right? This is some brilliant stuff right here. Any questions on the idea, like our goal? Good. So that is the idea behind a contradiction proof. All right.